So today we are going to discuss about the another algorithm which is called the dynamic voting protocol, which is going to subsidize the demerit of the static voting protocol. Because if we take care of this static voting protocol, having with an example that suppose we have 4 replicas at the 4 different sites, and the votes which are assigned to the different sites are 1, V2 is 1, V3 is 1, and V4 is 2. So now suppose the site number 4 is going to fail. So what happens? When the site 4 becomes unreachable from the rest of the sites, either due to failure or due to the partitioning of the network, then in that case, site 1, 2, and 3 can still collect a quorum. While site number 4 is not able to collect the quorum. And further, if there is another partition which is being done in a particular set, making any site unavailable out of 1, 2, 3, then in that case the system will not be able to serve any kind of read or the write request, as a quorum cannot be collected in any kind of partition. So it means the system will be completely unavailable, and that is not the requirement. So for that particular purpose, dynamic voting protocol can be used, which will be able to solve the problem by adopting the number of votes, or you can say the set of the sites can form a quorum by changing the state of the system just because of the failure of the site or the failure of the communication. So in this case, dynamic voting protocol, we have 2 approaches. The first one is majority based approach, and second one is the dynamic vote reassignment. So in this majority based approach, the set of the sites that are the majority dynamically altering by doing the alteration dynamically just to enhance the availability of the event of the site, even if there is a so the set of the sites which are the set of the sites that can form a majority are those who are, and those sites are updated when the most recent update was performed. So that is why we are going to frame the set of the sites in which the most recent update has been performed. And for that particular purpose, a partition graph is used to represent the history of the network failure as well as the partitions, as well as the recovery. So this is a kind of a partition graph, and in this partition graph, nodes are representing the partitions and edges are representing the further partition of the network. So further partition of the network, or you can say the recovery also. So in case of recovery, 2 or more partitions can be merged into a single partition. So in this particular figure, the root node, which is A, B, C, D, E, this root node corresponds to a system with 5 copies stored at the 5 different sites, A, B, C, D, E. These are the name of the sites, and which they have only one partition, single partition. Now this indicates that all the sites are connected, and all the replicas which are available at these sites are mutually consistent. Now the initial single partition is fragmented into two parts, A, B, D and C, E. Later on, D is isolated from A, B, D, and further B is isolated from A, B. And later on, the site A and the site CE are merged together to form a single partition, that is ACE partition, which is going to allow the access of the data, assuming that each copy which is available at these sites are having single port or one port. Now, in this majority-based approach, once a system is partitioned, the protocol is going to select one of the partition where the read or the write operations can be performed. Now, the partition selected is one which could have, which will be able to form a majority in the configuration that existed before the partitioning. And the sites that belong to the selected partition will be able to collect the quorum. Whereas the sites in the partition which are not selected will not be able to collect the quorum. So in this particular approach, the site A, B, C, D, E, site A, B, D, A, B, A, and ACE, they are able to obtain the quorum. But C, D, and B is not able to obtain the quorum. Now, this particular algorithm, which is majority-based approach, in this particular approach, it is already assumed that each replica which is available, it is stored at the different sites, distinct sites, and the protocol requires that the replica are ordered linearly, and each replica which is available at the different sites are associated. Each replica is associated with three kinds of variables. The first variable will be the version number. The second one is the number of replica updated, and the third one is the distinguished site list. So let us first discuss about the version number. So the version number of a replica at a particular site I can be represented by an integer that is able to count the number of the successful updates to that particular replica at a particular site I. So we can say that initially the VNI, which is showing, which is representing version number of the site I, initially it is set to 0, and later on it is incremented by one after every successful updates. So VNI is representing the version number. Second one is the number of replica updated. It is also an integer which is represented by RUI. R stands for replica and U stands for updated at the site I. It is represented by integer that always reflect that the number of replicas participating in the most recent updates. So initially RUI is equal to the total number of the replicas. And the third one is the distinguished site list. This distinguished site list at a particular site I is represented by a variable denoted by DSI, and the purpose of this is to store the identification of one or the more sites. Now, the content of DSI depends upon the RUI. When RUI is even, means the number of replica which are updated recently, most recently, if it is even, then in that case DSI identifies the replica that is greater than all other replicas that are participating in the most recent update of the replica at the site I. So if it is even, then the DSI will be representing, identifying the replica that is greater than all the other replica that is participating in the most recent update, that is at I. But if Ri is odd, then in that case, DSI is considered to be nil. But even though if it is odd, but the value of RUI is, if it is 3, then in that case, the DSI list will contain the 3 replicas that are participating in the most recent update, from which a majority is needed to allow the access of the data. So these are the 3 variables which are associated with each replica, that is version number of replicas updated, and the distinguished site list, which are of more concern related with the majority approach of the voting protocol. But before going to explain the detail about the majority approach protocol, majority approach of the voting protocol, let us start with an example, and then we will explain that how this protocol works. Now, the example is given here. In this example, we have 5 replicas which are stored at the different sites A, B, C, D, E, and the state of the system is represented in this particular table. Now, in this particular table, it is shown that each replica is already updated 3 times. Each replica is updated 3 times. So the version number of the replica at each site will be 33333. And RUI means RU at A and all the sites are 5. It means all the sites are accessible by every site. And in this particular case, DS will be irrelevant. Why DS will be irrelevant? Because as we have explained earlier, that if RUI is odd, then DSI will be nil. So that is why, since RUI is odd, 5, and it is not 3. Since it is not 3 and it is odd, so DS list, it is irrelevant. So nothing will be there in the distinguished site list as far as the concerned with the value of RUI that is equal to 5. Now suppose there is a site B which receives an update request and finds that it can communicate only with the site A and C. Then B determines that the latest version of the replica in its partition meaning thereby, since B is receiving and it can communicate with A and C, so the partition will be A, B, C. So the B is able to find that the latest version of the replica in this partition A, B, C, the latest version is 3. And the number of the replicas which are updated, which are last updated, is 5. Number of replicas are 5. Since the partition ABC has 3 of the 5 copies, then B is going to decide that it belongs to the distinguished partition set and processes the update. Now, because these 3 sites participated in the update, that is A, B, C, so the RU will be changed from 333 to 33. The updated sites are 3 only, because A, B, and C are going to be updated. So it will be having 333. And since they have updated their the information, so the version number which will be available with A, B, C will be 444, and the distinguished site list will contain ABC, ABC, and ABC, because all all these three. Now here the RUI is 3. So when the RUI is 3, the DSI list the three replicas that have participated in the most recent update form the majority to allow the access. So that is why this DS will have ABC, ABC, ABC. So the version number will be updated by 1. The number of replicas which are updated is 3. So here it will be 333, and only ABC has been updated, so 333. And the distinguished site list will contain ABC. Now, suppose the site C is going to receive an update and find that it can communicate only with B. Now, it will try to discover that the latest version is 4. Since C is receiving an information to update and it knows that it can communicate with B only. So it means the set will be B and C only. So the latest version which is available with B and C was 4, and the RUC was 3.3. So the protocol is going to choose the static voting protocol, because the reason why the static voting protocol is to be used when the number of replicas are 3, as per the protocol which is given by the person. It has been found that static protocol performs better than the dynamic protocol with the RU is equal to 3. So since DSC is at the particular site C is ABC, so B and C can form the majority among the ABC, and therefore C processes the update. Now when the C processes the update, it is going the system will change its state, so that since B and C are participating in the updation process, so it will become 5 and 5. There will be no change in RU because we are applying an static voting algorithm for making the updation. So there will be no change in RU, and there will be no change in the distinguished site list also, because we are applying the static voting algorithm. But the version number of B and C will be changed from 4.4, it will become 5 and 5. Now, since we know that the site B and the site C are not going to change the RU as well as the DS, because it is using the static voting protocol. Now, next, when the D is it is going to receives an update and discovers that it can communicate with BCE. D is receiving an update and it knows that it can communicate with B, C, and E. And the latest version which is available at BCDE, BCDE, the latest version is available is the 5. And it also knows that RU is already 3. So a majority from DS, the majority from DS means the ABC. The majority has to be asked from this partition set, that is ABC. And this ABC is available. So since the partition, this BCDE has 4 sites. So the BCD, the replica will be updated all these 4 sites. So RU will be changed from 3 to 4, and here from 5 to 4 and 4. Since this RU is become even, so DS, what will be the DS? Let me give you. If the RUI is even, DSI identifies the replica that is greater than all the other replicas that participated in the most recent update at I. So that is why, since D has to make an update, so that is why, and BCE are the latest, and the latest version is available is 5. So whenever it is being updated, so it will become 666, and the total number of the sites which are replicated, which are updated, is the 444, because 4 sites have been updated. And RU is even, so DS is set to B, which is the highest in the order. So it will become B, B, B. Now, suppose the C is going to receive, C is going to receive an update, C is going to receive an update, then again it tries to find out that to whom it can communicate. So C can communicate only with B. It finds that it can communicate only with B. So it means there is a partition called BC in the form of a set. And this BC contains exactly half the sites in the partition and contains the most uh, uh, the distinguished site, that is B. So this update is being carried out in the partition B and C, and so B and C will be updated and it will become 7 and 7. So whenever the C is going to receive an update, it finds that it can communicate with B. And BC has half of the sites in the previous partition and has the distinguished site B. So it is update can be carried out and updation has been done in this particular partition, and resulting that the version number will be changed. RU, since two sites are participating, so it will become 2, 2, 2, and DS will remain as it is, B, 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 and so on. So this is how the majority approach used to work. Now the protocol, how it works. The first step is that the site which wants the update, first of all, it sends a request, it issues a request in the form of a lock request to its local lock manager. And when this lock is being granted, the site I is going to issue a vote request to all the sites. So whenever the sites which are receiving the vote request from the site I, suppose site J is going to receive the request, what it will do? It will issue a lock request to its local lock manager, and if that lock is granted, J sends. Now the site J sends what it sends. It sends the version number, the total replica updated, and the distinguished site. Whatever is being maintained at the site J, that site J will send all these values to the site I. Now, once all the responses has been received at the site I is going to decide whether it belongs to the distinguished partition set or not. And how it will decide that whether it belongs to the distinguished site or not, that will be coming later on. If the site I does not belong to the distinguished partition, it issues the release lock to the local lock manager and aborts to the other sites, which make the release lock to their local lock manager. Means the other sites, whenever they are receiving the abort message, they are going to issue a release lock to their respective local lock manager. But if the site I belongs to that distinguished partition, then it performs the update. So if I belongs to that particular partition, distinguished partition, it is going to perform the updation process, and it is going to perform the updation process to its local copy if the local copy is the current copy. If it is not, it will try to obtain the current copy from one of the other site, and then it performs the update. Now, along with that replica update, it is also going to update the version number, the number of sites where the replica has to be updated, as well as the distinguished site list. These all also updated. And then site I is going to send a commit message to all the participating sites along with the missing updates and the values of VNI, RUI, as well as the DSI. And then it issues a release lock request to the local lock manager. Now, when the site J is going to receive this commit message from the site I, it is going to update its replica, updates the variables, that is BNJ, BNJ, RUJ, DSJ, because we are working at the site J. and then it issues a release lock request to its local lock manager. So that is all